Hello everyone, I'm just going to give it a few seconds to let people get into the stream and then we'll get started. Oh, there we go, that's a lot of people here today. So let me get started. Hello. Welcome everybody to the Code First Girls Introduction to Coding. We're on our very first session, MOOC session 1. I think I've picked the wrong banner. Apologies. I have done the wrong thing. Have I set the right one? Apologies. I may have the wrong set of slides. I'm going to probably hop over in a moment. Apologies for that, off to a good start. But basically, we're looking at a MOOC session just on what is coding. I have got the wrong set of slides. Apologies. This is what you get for hosting so many MOOCs. Sorry, Addie, I'm probably going to steal yours. If you could hop back to the previous slide. Apologies. Apologies for making you do all the work. Apologies, guys. So good start from my end. Apologies for that. So I'm just going to say hello and keep it nice and short and sweet because I know we have a lot of content and things to get through today. So just a quick intro to myself. My name is Marge. I am a software engineer, currently at Business Insider. So if you've seen all things like journalism and kind of interesting and different video content, that's a lot of what we do. I'm also here with Addie, who is going to be our lead instructor. Addie, do you want to give yourself a quick intro?
Thank you so much. Hi, everyone. I'm Addie. I'm a software engineer. I currently work for Thales, actually through Code First Girls. So I've done CFG degree, a few of the courses, and a mid-level accelerator, and teach with Code First Girls now as well. So that's me in a nutshell.
Awesome. Thank you so much, Addie. Just to say hello, obviously Addie is going to be the one leading this course and going through all of the content with you. But I am here as your host. So if you have any technical questions or any questions about Code First Girls, other courses that are offered, or any queries about this course, please don't hesitate to let me know. I can see loads of you being really active in the chat, and I would love to see that. This is a safe space for getting to know each other and asking questions. There is no such thing as a silly question. So please keep going with the chat. And we're really looking forward to this. Are you able to go to the next slide, Addie? Thank you so much. So yes, we have our tech checklist over here. So basically at any point, if you can't hear me clearly or Addie, or you can't read the slide clearly, please do let us know. There could be a technical issue on our end. Of course, we're doing everything we can to make sure you can hear us. But if at any point you're stuck or you're concerned, please let us know. If you're maybe unable to understand my Belfast accent, which is totally understandable, happens all the time, you can also use the live caption settings in Chrome to be able to see live text as myself or as Addie speaks. As I said, any technical issues, please do let us know. But it's good to hear that on the chat that people can hear me loud and clear. That's great. So next slide, please. So awesome. We're here at week 1, our introduction to coding journey. So obviously we're going to go through a couple of different sessions. We have 4 sessions in this MOOC, and we do have a challenge as well, which we will talk about a little bit later on, but don't worry about that just yet. You haven't signed up for the challenge automatically, so don't feel like you have to participate in anything. We're not springing anything on you. Right now, this is just a MOOC to get an introduction to coding. So next slide, please. Okay. So upon successful completion of this course, you will be eligible for a shiny, really lovely Code First Girl certificate, which you can put on your LinkedIn profile, you can share in your CV, in job applications and things like that. So it's a really good thing to have. You may be asking, how do I get the certificate if I'm just watching these videos? So at the end of each week, at the end of each session, you'll be sent an email with a link to the quiz. This will also be shared in the MOOC Slack channel. So please do keep an eye out for that. Once you complete those quizzes, you need to get full marks in each of them, but don't worry, they're not like 100 questions or anything. But once you pass all 4 of those quizzes, you'll be eligible for that certificate. And you'll also be eligible to start one of the Kickstarter classes, which we have, which are a little bit longer and maybe a little bit more intense. but they're a really good way to expand upon your coding knowledge. I did see a question which just says, are we able to watch the content after the live session? Absolutely, yes, you can. So once the session is complete, you'll be able to access the video at the same link that you're currently on now. So you can revisit these at any point. Awesome. Next slide, please, Addie. Okay, so that is enough of my spiel. I will definitely have the right slides for next time. But what I'm going to do is just drop a little link to the Slack channel in the chat. If you haven't already joined, I definitely recommend it, just so that you can reach out to us in between each of these sessions. But right now, I'm going to hand it over to Addie, who is going to lead us through our first session. Over to you.
Thank you so much. So before I get started as well, I'm just going to go back and say thank you to our hosts, Bank of America, because we didn't see that slide quite so much, but you'll also hear from Bank of America if you decide to do the challenge. So thank you to them. So fabulous, yes. Hi everyone, me again, Addie. So yeah, I'm a software engineer, as I mentioned. I primarily work with back-end stuff, which means that I don't really make code that displays pretty things for you. I make code or talk to computers to facilitate things that happen in the background. But we can get into that throughout the session and throughout this MOOC. And if you have any questions about my journey, Marge's journey, anything at all, just ask us and we can tell you about it and try and help you with your journey. But also, yeah, any issues with the MOOC this evening, like any technical difficulties, just pop in the chat to Marge. I've just let Marge know as well. I can't actually see your chat right now, so please don't think I'm ignoring you. If you do ask a question, Marge will let me know about your questions and I can see it, but I do have access to Slack. So any questions outside of this live session, or for those of you that are watching it recorded, let's talk on Slack. Please do try to put messages in a public area. I'm not too sure. I'll say whereabouts is the best place on Slack, because if you've got a question, likelihood is someone else will have it, and it might be beneficial for all. But absolutely, if you don't feel comfortable putting it in a public place, message it to myself, and if I think it would be beneficial, I can try and let everybody know, like, hey, just this bit of information. But session one, what is coding? So what we're going to look at today is the big question of what is coding? High and low level programming languages. So do not worry if you've never looked at a line of code before. We're going to go through some of the terminology today, and we'll actually look at a little bit of code as well. I will let you know now as well, if you are wanting to follow along with anything I do, I will only show you a light bit of code today, but it will be Python. You don't need anything installed on a computer. You can even do Python on your phone. So I will let you know of a website. You can look at it now. There's loads of online resources where you can use Python online. One that I particularly use is called Programmers. If you just type in Python online compiler, you'll find something. But we can get to that when it comes. So then the next point we'll look at is compiler versus interpreter, basic concepts in programming, and data types. So topic one, what is coding? So I'm going to go through what is coding, what is code, who is a programmer, coding in different languages, overview of coding languages, and overview of programming languages. So what is coding? Coding is how humans communicate with computers and tell them what to do. So through coding, professionals can build programs, including websites and apps, build lots and lots of stuff. Sorry, just checking if there's anything else on that side. So what is code? So we've just discussed what coding is. What is code? Code is what makes the programs or apps you use every day run smoothly and provide a seamless user experience. So have you ever stopped to think about ways that programming impacts your daily life? If you're here, you probably have done. But think every time you use a smartphone, laptop, any other electronic device, you're interacting with code that's carefully crafted by programmers or developers. One thing that is one of my past experiences is actually finance, particularly sending transactions. So I know a lot about the code that is involved when you click send money to someone. There's so much code involved along the way. Other examples, if you use things like Reddit, that's built with a language called Python. Facebook uses something called PHP for its front end. These are probably all things that you're like, I don't know what you're on about right now. But you might have heard of some of these terms before. There's something called Java, which is a programming language, my personal favorite, that powers the popular game Minecraft, and there's so many more. You'll be able to find out languages that program anything with a quick search online. So what is code? What is code? I think this is perhaps what is programming. But what is programming perhaps? It's the process of writing code to solve a specific problem or achieve a specific goal. Or it could be what is coding. So code is a set of instructions that tells a computer or device what to do. Because you can't just say to a computer, you can't just write down the words, hi, please can you do this, make this functionality. Obviously in the world of generative AI, you can get computers to do that for you, but your laptop that you've got in front of you might not understand. So another example, when you add two numbers or check your calendar, attend a virtual meeting, browse the internet, you're using code. I'm sure we are all starting to understand that being here today, you are using so much code. So who is a programmer? So we just looked at, I know that the slides said what is code, but we looked at what is programming. So who is a programmer now? So a programmer is someone who analyzes a problem and creates a solution in code. To do this, they follow a specific syntax or set of rules for writing the code. You might also hear a programmer referred to as a coder. You'll also hear terms like engineer or developer. They're generally the same, but they can be a little bit different. So we can discuss that if anyone has any questions. So programming languages is what a programmer uses, and programming languages are used to write code that computers can understand. So as I mentioned earlier, we cannot write a task in plain English to a computer and expect the computer to understand what we mean. You can't just say, computer, do this. It doesn't strictly know how to do that. It doesn't understand what you're saying. It doesn't speak the same language. So in the next slide, and for the rest of the session, we will see how to interact with computers, but particularly in the next slide, we will see some examples of a program written in different coding languages. So the aim of the program you're about to see is to add two numbers together. Now, I'm just going to warn you, not expecting you to be able to understand it, so don't stress. I remember when I first saw a piece of code, I was so overwhelmed. So on the left here, we have an example of something called C. So C is a very, for lack of a better term, it's a very old school coding language. It's not to say it doesn't have its uses. In my current place of work, they use C, and we can absolutely look online, or you can have a look online at different uses for different languages. So this is an example of C programming language to add two numbers together. This one in the middle is very, very tiny, but I didn't state it at the beginning. I will be giving you access to the slides. I think I have already added them into the Slack workspace in a bookmark in the announcements channel. But if not, it will be done after the session tonight. So yeah, this one in the middle, I can't even see it. It's so tiny, but you'll be able to zoom in on the recording perhaps. And that is Java and how to add in Java. So you can already see that they are not the same. Even if you can't read what it says, there's a different amount of lines. And then this one on the right-hand side is Python. You can see that that's a lot shorter because Python is generally for short little commands or for using it as a calculator and stuff. It is generally a quicker and easier one to write. And we'll go through why it's a quicker and easier one to write throughout this session, actually. Brilliant. So we'll move on from that. So overview of coding languages. So each programming language has its own rules and syntax. This word syntax, we picked up on it a little bit a few slides ago, but it's it's the words, it's the language, it's the way that a language is written. So there'll be a better definition online, but that's what it is. Syntax is just how it's written. So what works in one language might not work in another. There are lots of similarities, but then they don't always translate. So for example, to print hello world, and if you're the same as me, I was like, what is print? What do you mean by that? By print, I mean display something using code. So you can get your code to display something to you. So you can write a bunch of code, and then when it's doing its thing, you can get it to sort of speak to you. It will show you something, also known as printing. So to do that in Python, it's quite nice. We write this particular thing called print, which is something called a function, but don't worry, we don't know about that yet. We say print, brackets, and then within those brackets, you put in what you want to print out. But if we wanted to type the same line of code in JavaScript, if we just wrote exactly that, print, open brackets, speech marks, hello world, that would give us an error. Same as in Java. In lots of languages, that would give us an error. So in JavaScript, that bit that's written in bold, the print hello world, to translate it into JavaScript, it would be console.log brackets hello world. So you can see it's quite similar in some ways. They've both got the brackets, they've both got the speech marks, but we don't use, one uses print, one uses console.log. So don't worry, not expecting you to understand this bit yet. We will look at that print bit a little bit later, but just to show you what we mean when we say different coding languages are written differently. So whilst there are differences between programming languages, there are lots of similarities too. So for example, I've got a few years of experience, but if I saw some code in Java, I would be able to translate it into Python, and I would be using sort of the same structure. If I was trying to do something where I'd say like, if today is Monday, print out today is Monday, the code would actually look quite similar. There would be different words used, but the code would look quite similar. So the reason the code would look quite similar is because most languages share core concepts and functionality. So learning one can make it easier to learn others. So I know that in Python, if I want to print something out, like if I want to display something to a user, I know that there is a way to do that in Java. It's just different words, but it's the same concept. So I can think in my head, okay, I want to print it out, and then I want to add these two things. I just need to know the syntax or the terminology for those different languages. So concepts like variables, constants, conditionals, loops, and functions are the same across languages. Now, I'm not expecting you to know what those are. We do go through some of this terminology today. But yeah, if anyone is aware of what those are, they are similar across languages. Oh, and as mentioned, we'll learn about these concepts throughout the book. So we've just gone through what is code. When someone says code, what do they mean? And when someone mentions programming or says something about a programmer, what do they mean? We also mentioned that there are different terms that might be used for those. So next, topic 2, we're going to look at high and low level languages. Went too eager there. So we're going to look at low level programming language and high level programming language. So low level programming languages. So we can split programming languages, and I'm just going to stick to saying languages for now. We can split languages into 2 categories, low level or high level. So low level, these are closer to machine code that computers understand, and they're more difficult for humans to read and write. So yeah, it's closer to machine code. So they're designed to be more efficient for machines to process, but obviously they're less user-friendly for humans. So yeah, I just mentioned that bit. And in a nutshell, they're more like zeros and ones, which is referred to as binary. So you might have seen on like some films when they're talking to computers, especially like older films, you'll see like zeros and ones, and that's binary, for example, here. I don't know about anybody else, but I can't look at that and go, I know exactly what's going on. A computer can, though, because a computer will be able to understand that low-level language. So on the other hand, we have high-level programming languages. So these are easier for humans to read and write. This is what, if you go into a career using code, you will likely use these a lot more. So they do need to be translated, though. So it's great that you'll be able to understand the code, but the computer's not going to be able to directly understand it. So it might need to be translated before a computer can understand and execute the code. So some examples of high-level programming languages that we've already discussed are JavaScript, Python, Java, C++. Now, it's down to personal preference as well. Some of you will find some of these languages easier to understand than others. It really just depends on how you learn, how you use the language. But Python, the one that we will look at if we get time at the end of the session, is generally a little bit easier for people to understand.
Addie, we've just had a great question come in, just from Nesrin here. Are HTML and CSS programming languages as well?
I always get the terminology wrong. So they are languages. I don't know if they're classed as programming languages. Marge, do you know the answer?
That's why I'm asking. I believe it's the same. It's not actually a programming language in the same way as things like Java and JavaScript. But I also cannot remember the terminology.
So I've just done a little search online because I always used to think, yes, they were, because you think like, oh, I'm just going to write some code. But no, they are not considered to be programming languages. And it's due to the logic the way that you write them, and there's no logic involved. Sorry if you heard a cruise ship there. So for example, if you look at CSS, I think that's a lot easier to understand. Perhaps get some up later, or I can show some in Slack if someone reminds me. If you look at CSS, there's not really any logic there. You kind of just say, consider this box. By the way, I don't deal with CSS. I don't like it. But you'll say, this particular box, I want it to be this color and it's going to have this font. But you don't say, I want it to do some calculations and stuff like that. But I am not the authority on that. So I would recommend people look into it a bit more. Short answer is no, they are not programming languages.
This is what you get when you ask back-end engineers my front-end code. Thank you for answering the question.
Thank you so much. Yeah, I do not like HTML or CSS because, I don't know, I just find it a lot easier to write code that's doing something, saying like, I've got this money, I want to move it through, as opposed to, I've got this website, I want to make it pink. It's a lot more fun and creative. My brain doesn't work that way. Fantastic. So thank you so much. I know I can't see people's questions, but it's really great to see how engaged we all are. So thank you. So back to high-level programming language. So ones that are easier for us to understand. So we might see something like this little bubble to the left. So we might write that. And if you have done maybe a bit of maths before, or even if you just look at it closely, you might start to understand what's going on here. So we have A plus B. And if we think back to, what is it, BODMAS or BIDMAS in school, brackets, indices, division, whatever, we can add those together. So A plus B plus those. And then this slash means divide and then by 2. So that's what we're doing here. I can look at that and start to understand what's going on. But then the computer doesn't, so then it goes into a translator, and then it puts that into machine code. Now, all different languages will do this slightly differently, and we'll get on to that now. So topic 3 is compiler versus interpreter. So we will look at what is a compiler, what is an interpreter, and then compare the two, compiler versus interpreter. So a compiler is a program that translates source code, so the code that we write, written in a high-level programming language, like Python, into machine code that a computer can execute. So I'm just going to repeat that without me interrupting it. A compiler is a program that translates source code written in a high-level programming language into machine code that a computer can execute. So the machine code is usually in the form of an executable file that can be run on the computer. So an example of a compiled language is C, C++, Java. So Java and C++ are like children of C. So that's why they're all very similar in how they run. So this is where a compiler comes into things. So we have the source code, that box in blue. So what we write, that goes into a compiler, the shape in yellow. And then that goes into machine code for the computer to understand. And then we might have an output or whatever the result of our code is. So that's what a compiler is. An interpreter, on the other hand, is a program that executes instructions written in a programming language without first translating the instructions into machine code. So the interpreter reads and executes the instructions one line at a time, converting them into machine code as it goes along. So an example of this off the top of my head is Python. So you could write 1,000 lines of Python and it will look at the first line and it will read it and execute it. And then it will move on to the second line and it will read it and execute it. Whereas in Java, you could write 1,000 lines and it will translate it all first and then it will run it. So you can get some differences in how quickly you might see outputs and how quickly you might see errors and stuff. And I'm happy to discuss that if anyone has any questions at this stage, but I'm aware it's a lot. So to put it into diagram form, source code, the stuff we write, that goes into an interpreter that goes into an output. So you see we miss out that compiler into machine code step. Sorry, I'm aware you can't see me. I was just taking a drink there. So compilers versus interpreters. So both compilers and interpreters execute instructions written in programming languages, just in different ways. So compilers translate the entire program into machine code all at once, while interpreters execute the instructions one at a time as they are encountered. So this means that programs that are interpreted may run slightly slower than programs that are compiled, because the interpreter has to do extra work at runtime to translate the instructions. But on the other hand, it can be a little bit more efficient. There's lots of considerations between different languages. So final point, however, interpreted programs have the advantage of being more portable because they do not need to be compiled for each specific type of computer. So we've so far this session, we have discussed what is code and what are languages and how are these languages ran? Like how does a computer use that stuff? And you can absolutely go much, much deeper into these topics. And if you want us to go through that at any point, just shout. And I believe there is a question.
Yes, we have a question from the CJ. So in what context would someone prefer to use the compiler approach instead of an interpreter? I guess, is there like an advantage?
So why might someone want to use a compiler instead of an interpreter? So a compiled language, if I just think off the top of my head, why might I want to use Java as opposed to Python? I know that once I have written my Java code, so a compiler language, as soon as I run it, I know that there are no errors remaining in what I've written. I've not written a word incorrectly because as soon as my program is running, all of the code has already been translated. So I know that it couldn't do that if I'd written something wrong. Like if I'd misspelt something, it couldn't translate it into machine code. But say if I had written something incorrectly in an interpreter language, I won't know that I have misspelt a word perhaps until it goes to run that specific line. So that's just one very niche example. There will be loads and loads of examples though of why or why you might not. Do let me know if there's a follow-up on that one though.
Thank you.
Thank you. So let's move on from that and let's go into basic concepts in programming. So we're going to look at what are keywords, what are variables, and what are constants. Now, I will preface this as well with when people have learnt to code, or when people get a little bit more comfortable, they will use terms interchangeably and they will not always say the correct thing. So for example, compiler and interpreter, if I'm not being careful, I might mix them up. So you learning this now, you are the authority, you will know the difference between these things. But if you ever think, oh, Addy, you said this term, but I think you meant this, or I'm not too sure, do just shout. It's always good to check people, especially people who have been coding for a few years, because they might get lazy and use wrong terminology. So most programming languages share some basic concepts. That's what we're going to get into, such as keywords, variables and constants, and data structures. We're going to have a look at keywords and variables and constants throughout today, but data structures is something very interesting and much bigger that we're going to look at next session. So what are keywords? So every programming language recognizes specific English language words. These are referred to as keywords. So keywords can differ for different languages and form a core part of the functionality of a programming language. So on the left here, we have some keywords in Python. So that does not mean that they are keywords in another language, but these are keywords in Python. We won't go through all of these, but let's just pick some out that might be nice to go through. Fourth one down on the left, and. It means what you think it means, and we won't see it as such today, but the context you'd use it in is if you are saying, do this and this. Well, it's more for conditions. So it's more when you say, hey, I want to do something based on a condition. And you can say this condition and this condition. But don't worry, we're not looking at that today. That was just an example. And another thing we can look at that might be a little bit easier to understand, import. So third column in, so this one that starts with from, and fourth one down, import. It imports something, particularly it imports other bits of code. So I might be writing code in a particular file, and I might say, Marge has got some really handy code. I don't want to write that myself. I'm going to use Marge's code. So I would use this keyword import, and Python would know, like, okay, fantastic. I know that you wanted me to get something from somewhere, and then I'd give the location of Marge's code, and then we could use it. JavaScript, on the other hand, not a language that I am too familiar with. Here are some keywords in JavaScript. And again, the reason I'm not too familiar with it is because it is typically used for websites and stuff that you will physically see, which is not what I code. But an example that we can go to is if. So second column, very close to the bottom. So the column that starts with do at the top. If is the second to the bottom. And if is exactly what you think it is. You say, if something happens, do this. So, you'd say, if it's sunny, I want to go outside. That sort of thing. You say that to the code. Obviously, code can't really go outside, but you could say, if it is sunny today, how you define that it's sunny today is up to you, then do something. So if is an example of a keyword in JavaScript. So every programming language, therefore, has its own set of keywords. There are some that are shared between them, but it's not a guarantee, so never assume that. So these keywords are part of the syntax and core functionality of the programming language. So the compiler or interpreter, depending on what language you're using, will read these keywords and the syntax of the language and translates it into perhaps zeros and ones, like binary or machine code. so the computer can understand it. So what are variables? So we've just looked at what are keywords. We're now looking at what are variables. So variables are names that we assign to a value in a computer program. So this is something that really confused me at first. Don't worry if this also takes a while for you to settle with. So variables are useful because they allow us to store and manipulate data in a program. One can also change the value of a variable, depending on the language, so it can be used to store different pieces of information at different times. So we'll see how to do that in Python today, but here's an example without looking at any code. I'll get onto the example shortly, but variable names make them easy to identify in a program. So for example, you could create a variable called age and give it a value of 20. This would be like putting the number 20 inside of a box labeled age, and then later on, you could use the variable age in your program to refer to the value 20. So you could set that once, you could write age equals 20, and then 1,000 lines later, hopefully not 1,000 lines later, but you then might say, okay, I want to do something with age, and rather than writing the number 20, you would refer to age. And then that just allows you to have one place where it's really clear that it's defined, but it can also be easier for you to update values as well. So say I use this age variable loads throughout my code, but I've only set the value once because I say age equals 20, and then I just refer to age throughout. If I then have my birthday and I want to update my age, I'm not 20, I wish I was 20 still. If I wanted to update my age, I would just have to update it in one place. But don't worry about that too much for now. The key thing is to just appreciate the concept of a variable. So as mentioned, variables are names that we assign to a value in a computer program. So here is an example. So this is actually an example from Java. So we have in green this top line. It says int age equals 20 and semicolon. So int, in this case, for Java, you have to say what data type your variable is going to consist of. So the actual variable here is age. That word age that we've written, that is just something I've come up with myself, or whoever wrote this. You could call it anything, but we say age equals 20. The additional code is this data type here, int. So int is short for integer, which means a whole number. And this is a concept throughout every language. Integer, whole numbers. So I couldn't have 20 point something because that's not a whole number. So the data type is int, the variable name is age, equal sign is assigning a value to that variable, and then we give it the value 20. Now this semicolon is one of the lovely quirks of Java. You have to finish your lines with a semicolon to allow the compiler to know that you have finished a command and you wish to move on. Any more to note onto that? Oh, as well, so this is going more into the core, like how the computers work. Once you define that variable, there is then some reserved memory for that variable in RAM. I don't know much about core computers because I just use the software. But this will also differ between different languages, and you can get really deep into how different languages store information and how they work. So that was very deep onto variables, but we're not finished yet. So variables have a specific data type, which determines what kind of value they can hold. This will vary between languages. So as you just saw for Java, you do have to say, you have to tell it what data type the variable will be. But in different coding languages, it will just figure out what the data type is by what you define it to be. So variables have a specific data type determining what kind of value they can hold. Variables, as mentioned, take up space in memory. So how much space each variable takes depends a lot on the type of variable. So for example, there are different data types for numbers. Not all variables that are numbers are integers, because you might have some that have a decimal point. So this might be a float. You can also have something called a double. You can have, depending on the language, you can have bigger numbers. So they'll be able to store more. So integers in most languages will actually have a limit of how big the number can be. I can never remember, it's like 11 or 13 digits or something. But then when you go bigger than that, you might not be able to use an integer anymore. So you might use something called a big integer or something else, depending on your language. Brilliant. Anything else to hold that there? Yep, as well. So I've talked about numbers a lot, but it doesn't have to be a number. So some data types can hold numbers, others can hold text, others can hold different things like dates and stuff. So you have to choose the right data type for a variable based on the kind of value you want to store in it. Thankfully, in Python, you're not going to have to make that decision because it will figure it out for you. So let's see another example in detail, and this is actually going to be JavaScript. So here we have var, and again, I am not a JavaScript coder, so if you ever have a problem in JavaScript, I can absolutely take a look at it and try and help you, but it is not a language that I write myself. So don't think I am a pro at JavaScript. But even though I don't know JavaScript, I can look at this and figure it out, even without the points that are on there, because I know a different language. So anyways, we have var. Not 100% on JavaScript. For some things, this can mean var as in variable, but I would love for someone to go and figure out, or if people know what var actually means in JavaScript, please let us know. But the key thing here is name. I can see already that is our variable name. So we are creating a variable called name. Equals means we are assigning a value to it. And then on the right-hand side, I can see that we have put James Bond. And we have put this into, I always get the grammatical names wrong. Are those apostrophes? The single ones, apostrophes, I think. And that's because we are giving it some text. Now, typically, in pretty much every coding language, when you're dealing with text, you have to surround it by single speech marks or double speech marks. That is so that your whatever language you're using knows that it's handling data from you and not trying to read it as its own code. So if I dropped those speech marks here, so just after the equal sign, that speech mark apostrophe, whatever the correct term is, if I got rid of that, when this code comes to run, it will think that James and Bond are JavaScript terminology or something, or it might think that they are variable names that are assigned elsewhere. It will get all confused. So that is common throughout most languages. And you'll see here as well, we have a semicolon, which is the end of the statement for JavaScript. But if you're wanting to know JavaScript, please go and look into it more. There are definitely MOOCs that cover JavaScript as well, because I know that you don't always have to end a line with a semicolon. So just looked at variables. We're now going to look at what are constants. So a constant is a value that cannot be changed once it has been defined. Constants are often used to represent values that are used frequently within a program, but do not need to be modified. We'll try and think of an example if it doesn't show on here. Actually, let's think of an example now. What is a constant that I might use day to day? Fantastic. So when I worked in finance, I actually worked for a child company of Visa. So if I was sending a payment and the payment was coming from Visa, the payment's always going to be coming from Visa. That's the code. That's where we've ended up. That's never, ever going to change. So I would make that a constant, meaning that throughout the code, we can never change that. It will always have that set value that I have written down. But one thing for you to note that really confused me is a constant in your code. You can't edit it, but you can physically go and type when the code's not running. You can go and edit that at a later date. It doesn't like just fix your code forever and you can never edit that code. But yeah, so as mentioned, constant is value that cannot be changed once it has been defined and your code is running. So using constants makes code easier to read and understand because one can use a meaningful name for the constant instead of writing out the actual value every time it's used. That applies to variables as well. So constants, using them can also help prevent errors in code. This is because values assigned to a constant cannot be changed. So as I mentioned with that visa one, that's good because what if I wrote some code later on and then it tried to change the variable name of like sending bank and it changed it to something that could cause like a whole payment to fail because it has to be visa every time. Happy to think of some more examples, not just on the fly for you. If people ask me in Slack, I can think of some and give them a bit more thought. So in most programming languages, constants are defined using a special syntax, such as the const keyword in C, or in Java, you use the keyword final. So before you go and make your variable, at the beginning, you say final, and that means this is going to be constant, cannot be changed. So what are constants still on that point? So we're still talking about constants. So for example, we can use a constant to represent the value of pi, which is a mathematical constant that's used frequently in geometry and trigonometry. So instead of writing the value of pi every time it is needed, we could define a constant called pi and give it the value of 3.14159. Then you can use the constant pi wherever you need the value of pi in your program. I'm just about to take a sip of water now. I will also just say that there will likely, whatever language you're using, there will likely be pi defined somewhere that you'll be able to get, just to throw that out there. Here is an example of creating that pi constant in Java. So ignore that bit in red that says static, because that's something that we're not covering today. But just note that things can be static or not static in Java. If you wish to look into that more, please reach out. I love Java. The key things here are final float, pi equals, and then the number, and then f. So let's break it down. In black, ignoring the semicolon at the end, so pi equals 3.14 blah, blah. That is saying that we're making a variable called pi. Equals means we're giving it a value. And then we say 3.14 blah, blah, blah. Those are numbers. So we're assigning a numerical value to it, but we're adding f at the end. And that is because in order to make something called a float in Java, which is just a numerical data type that allows for decimal points, and float is a common term in other languages as well. In order to make a float in Java, you have to put f at the end, just so Java knows. So we have pi equals 3.14 blah, blah, f. So that's creating the float. But remember in Java, we have to finish the line with a semicolon. And we also, before we say the variable name, we have to tell it what data type it's going to be. In later versions of Java, you can actually use something called var, which means you can be sneaky and not actually specify what the data type will be. But anyways, so we've said float there. The bit for constant, though, is final. So adding that final keyword is where we're saying this is going to be a constant value. Throughout the code, you can never change this. I could physically go and type over this, absolutely. But when the code is running, nothing will be able to update this. And let's have a look at the same thing, just translated into C. So we still have pi equals 3.14159. Note, we don't have to put f on the end. We finish it with a semicolon again. We specify the data type before the variable name, and in this case, it's float. And instead of final, we use const. So that's what constants are. And we're going to, oh, sorry.
Oh, sorry, Addie. I have a really great question. I think everybody would like an answer to. So, Goat Sorcery has asked, how come you don't put the apostrophes or single quotation marks around the pi section here? Is that the same for all constants?
Fantastic question. So I think you're saying, why don't I put the speech marks before 3 and then after 9 or F? So for numerical data types, and thank you for picking this up, I didn't actually specify it. For numerical data types, you don't need to surround it with speech marks because it will see a number and it knows that a number is a number. It doesn't use numbers for its own syntax. So for example, the number 3 doesn't mean anything to a programming language apart from being the number 3. But the word print, for example, does mean something to a coding language. That's why we would have to specify if we want it to be treated as data. So for numbers, you will never have to surround it with the speech marks because it knows that it's a number. But if you wanted it to be treated like the actual characters and treat the number like text, you would need to put the speech marks around it. So that's not to do with constants. That's just to do with variables and just numbers versus text in the coding languages. You will also, so numbers don't need the speech marks. But for other data types, you probably will need the speech marks just to make it clear, and it will depend on the language. But if I just thought of, I actually can't remember. I think Python for dates, for example, you would have that in speech marks. So it really just depends on the type of data that you are wanting, whether you have to put speech marks around it. But in general, numbers, numerical data doesn't need speech marks. Everything else tends to, but it's worth checking. Does that answer the question?
I think that answers the question. Yes, we've got confirmation. We're all good. Thank you very much.
Fabulous, thank you. But yeah, if anyone gets these questions popping into their mind afterwards, just drop me a message. So it's worth noting as well, just looking at the time, we're not going to get time to go through the Jupyter Notebook live. If we do get time, I will try and show you it. But if not, I'm going to pop it out into Slack and I will put some notes in Slack to support that. And then we'll have to go through it next session. But absolutely ask questions in the meantime. That was just a little disclaimer in case you were looking at the time. So next topic, data types. So what is a data type? We've already looked at it a fair bit, to be honest. What is a data type and classification of data types? So what is a data type? A data type is a classification of data that determines the possible values that a piece of data, such as a variable or a constant, can take, and how it is stored in memory, and the operations that can be performed on it. So we have to specify the data type of a variable or constant when defining it, depending on the language, and only assign values of the appropriate data type to it. So for example, if you define a variable as an integer, so you say to your code, it's going to be an integer, and we've already discussed that means a whole number, you can only assign integer values to it from there on out, depending on the language. So let's read that example and have Java in mind, because this does apply to Java. So if we define a variable as an integer, you can only ever give it integer values. You can't give it something called a string, which means text, like your name. Or you couldn't give it a Boolean value. Boolean means true or false, because you've said it's going to be an integer. Python, on the other hand, and I would encourage you to look deeper into why this is the case, because strictly underneath it will change the data type. But you could make a variable that is initially storing a number, and then later on you could give it a different data type. But if you properly assessed the data at each of those times, it would have the correct data type. So what do we mean? Where was it? There's a little bit I wanted to touch upon. The operations that can be performed on it. What do we mean by that? So for example, it makes no sense to divide or multiply text. I mean, if you think about it, you kind of can. But I wouldn't say I want to divide the word cat by the word dog. It doesn't work. That's an operation you can't perform. But that operation you can perform on numbers. So that's why it's really important. I also couldn't get the number 20 and say, make this uppercase. But you can do that on text, also known as strings. So we've seen this quite a bit now, but the data type is that bit before the variable name. So int in this case, which means integer. And again, it will vary on the language you're using. Some languages have data types that they know, it's core to them, and some data types that are made up after the fact. But we can get into that at a later date. So the final thing that I will show you today, and then I will just briefly show you the notebook. But please do pop any questions in the chat as you get them. If we don't get time to cover them all, take them over to Slack. So here's some very common data types. And thank you. I see there's a question that after I've gone through these, I will make sure to pause. If not, Marge will interrupt me. So integer, we've mentioned a lot this evening. A whole number could be positive or negative. Float, so these are common throughout different languages, is a number with a decimal point, such as 3.14 or minus 2.7. String is the coding programming language version of text. So it's a sequence of characters, such as a word or a phrase. You can also have a number stored as a string. Boolean is a value that can either be true or false. And then these bottom two are ones that I think might be a step too far today, but it's worth noting. An array is where we can have a collection of values of the same data type, depending on the language. So I could have 5 variables that I actually store together in an array. And then that bottom one, object, is a complex data type that can contain a combination of other data types and methods. We won't be covering objects in this MOOC. If you ever want to get deeper into that, the CFG degree is fantastic because that really goes in depth and you will absolutely cover objects there. So, to Marge for the question.
Absolutely. I think this is a really good question. So I'd love for everybody to get an answer instead of me just typing. So Joan has asked, can you use uppercase or capitalized letters for variable names in any programming language? I didn't want to get into like conventions in the chat. I thought that might be a bit crazy.
Thank you so much. And this is an amazing question. I will have several different points to say here. Generally, we would use lowercase letters. Actually, no, it really varies upon the language whether you use capitalized or lowercase. But if in doubt, if it's a coding language you don't know, stick to lowercase. It doesn't strictly matter, but there are conventions. So for example, in Python, you write everything lowercase in something called snake case, which is where you say I had a variable that is my name. I would put all in lowercase, my underscore name. But in Java, I would use something called camel case. So I would put my lowercase and then capital N and then aim. So my name. But you see, we're pretty much a standard using lowercase there, just different ways of indicating that there's like a new word variable. Using capitalized letters for variables is very uncommon. When you would use capitalized letters would typically be for a constant. And that is usually screaming snake case, which is where you separate the words using an underscore and you write in all caps. So if you ever see a piece of data and the variable name, it might not be a variable, but the name is in all caps, that typically means it is a constant. But it varies between language and it typically doesn't matter. There are just conventions. Marge, do you have any more to add on that? Because it's a very big question that could go many ways.
Yeah, I feel like you've answered most of it. Obviously, it is so dependent on the language. It's so hard to kind of pin it down. I think it's going to depend on, I guess, your own like personal preference and your own obviously your team's preferences if you're coding with a team. I know in my line of work I use a language called Golang, which is quite closely related to C and C++. And we tend to use things like camel casing, which is that kind of lowercase at the start, uppercase afterwards. But there's also weird conventions in Go where if you have something that's like an acronym, like URL, you write that in all caps, but not if it's the first word in your variable name. It's very confusing. So basically, we could spend another hour on this, but I really don't want to keep you here for another hour. The TLDR is it's complicated, and probably the best thing to do is to check the specifications or the kind of best practices for the language you're working with.
Thank you so much, Marge. So as well, I've been writing down different notes from what people have asked today, and I will try and give some more resources as well to help out. So that is a fantastic question, and I'm going to put a little bit more in Slack to help us out with that. So noting the time, I am going to have to wrap up here, but I'm conscious that there is something that we've not looked at yet called the notebook. So what I will do is, not immediately, I will share the quiz with you that Marge might speak a little bit more about, but you heard at the beginning. I will share that with you immediately, and you have access to this notebook. But you might not know how to use this notebook because it's a different file format to, say, like a Word document. So I will, if not this evening, later tomorrow, I will be supplying some information on how to actually interact with this file that I'm going to share with you. There'll be lots of resources online as well. And we will also definitely go through it next week. But yeah, just letting you know that we didn't get to cover that. I'll go through the recap and then hand back over to Marge. And it is all recorded, don't worry. So what have we covered today? A lot, and thank you so much for all the engagement. So we've looked at what is coding, high and low level programming languages, compiler versus interpreter, basic concepts in programming, data types as well. So these slides are in Slack. They're pinned in a bookmark. I believe it's called session 1. And then there is a quiz that you have access to. And remember, you need to do all of the quizzes in order to get the certificate. But that's more Marge's realm than myself. But I will be sharing that quiz with you as soon as we've wrapped up this call. And you will also get an email to you. But I'm taking over from Marge, so I'll hand over to Marge. But thank you, everybody.
Thanks, everyone. Yeah, so absolutely. Just a little recap before we go on, because I know people hear about the quiz and they panic. It happens every time. I'm here to tell you now, please do not panic about the quiz. You don't have to complete it tonight or today. The way that this works is you're going to receive the link to the quiz. Andy's going to share that out and basically give you an opportunity to complete that. The deadline for completing all of the quizzes, so there will be 1 quiz per session, there'll be 4 quizzes in total. The deadline for completing all of those is going to be 2 weeks after the very last session. So that is going to be, I believe, the 17th of July, which is the same, not the 17th of July. I can't read. The 22nd of July. So the 22nd of July is the official final deadline. We will post about it in the Slack channel, which is, again, why I'd recommend you all join that. I mean, I know a lot of people joined tonight, so you can hear my notifications going off because everybody's joined. But yes, keep an eye out on Slack for all of that information. If you don't receive any emails or you can't see the message from Addie, please reach out to either myself or the CFG programs team on Slack, and we will do our absolute best to assist you. So you do have plenty of time. So don't worry. We will keep you informed if there's any kind of date changes or anything like that. So don't worry about it at all. Right. I have kept you all back long enough, so please get on and enjoy the rest of your evening. I hope you had a really great first session with us. Again, if you have any questions in between now and the next session, do let us know. But until next week, we will see you all later, and good luck with the quiz. Chat to you all later.
Thank you.